Welcome everyone to our this video on the chapter of laws of motion. So, in the last class we discussed the concept of pseudo forces and how to apply the ideal pseudo force in some cases, some examples. So, we took the example of a block kept inside a elevator. A block is tied to a string and a man was trying to observe it. So how do we draw the forces on the block? So we learned that pseudo forces are those forces which are applied by the person sitting in an accelerated frame of reference. So whatever the acceleration of the frame of reference would be, that acceleration is reversed and then it is multiplied with the mass of the block which we are trying to observe, and that is what we call the pseudo forces. So let us proceed with the questions today. So question number 1, the first question which we are going to do today is this one. So we have two block and a pulley system which we have studied in previous videos. So there is a block of mass m1, there is another block of mass m2, and this whole system is assembled inside a lift, and that lift is going up with an acceleration a naught. So usually we have been doing such type of systems or dealing with such type of systems when the whole system is at, when the pulley itself or the ceiling specifically speaking is at rest. Now in this case the ceiling is moving upward with an acceleration a naught, and as a result of which the whole system seems to be moving upward with an acceleration a naught. Now at first observation it would seem that mass m1 and m2, yes, they would be having some different accelerations. The natural question which comes in the mind is that what would be the values of accelerations of mass m1 and m2. So let us choose the frame of reference of this elevator and let us try to draw the forces acting on the masses m1 and m2 in the frame of reference of this man which is standing in this elevator. So let us begin. So first we will be drawing the forces acting on the mass m1. So we have represented the mass m1 with a point mass, and the tension acting on this mass m1 is in upward direction. Let's say that tension is some T, and the downward force acting on the mass is the gravitational force. Its value is m1g. Now these are the forces which we usually draw on this mass m1 when we are talking about the frame of reference which is at rest, that is from ground frame. But what about the frame of reference of this man? We are thinking that from the frame of reference of this man, what would be the motion of m1? So we know that we will have to draw an additional force acting on mass m1, which would be the pseudo force. So we know that we will be reversing the acceleration of our frame of reference which is a naught, and after reversing that acceleration we will multiply that acceleration with the mass which we are observing. So we are observing m1 mass, so we'll apply the force m1 a naught in the downward direction, which is the reverse of the a naught acceleration, and apply on this mass m1 in downward direction. So after applying this pseudo force, now let us think about what would be the acceleration of this mass m1. So the acceleration of mass m1 can be considered in downward direction. Let's say it's moving in some downward direction. Let's say that acceleration is a. And now let us talk about mass m2. So the mass m2 would be also experiencing the same kind of forces, that is the tension T, the gravitational force would be definitely a different value but acting in downward direction only, that is m2g. What about the pseudo force? We can quickly draw the pseudo force again by reversing our acceleration, which is a naught, and multiplying with the mass which we are observing. So that is the important part. We have to reverse the acceleration of the frame of reference and we have to multiply not with the mass of the frame of reference but with the mass which we are observing. So in this case we are trying to draw the mass forces on mass m2. So we will draw the pseudo force on mass m2 and apply the acceleration with the mass m2. So m2 a naught, that is the new pseudo force which we have generated, and as we have considered m1 moving in downward direction, m2 would be moving up with an acceleration m. So again, writing the equations, the Newton's laws equations for mass m1 and m2. So for m1 mass we would get the downward force m1g plus m1 a naught minus the upward force, that is tension, should give us the acceleration for mass m1 in downward direction, which we have taken as a. And similarly for mass m2 we would write tension T minus m2g minus m2 a naught is equal to m2 into a. After adding these two equations we will get m1 plus m2 into g plus a is equal to a naught m1 minus m2 m1 minus m2 into g plus a naught is equal to m1 plus m2 into a. So this would give us the acceleration a equal to m1 minus m2 divided by m1 plus m2, and you would be remembering this expression from the Atwood machine system, that m1 minus m2 upon m1 plus m2, just the coefficient of this expression would change from g to g plus a naught. So this is the new acceleration of both the masses in the frame of reference of mass m1. And what would be the value of tension which is asked in the question? Find the tension in the string. So what would be the value of tension? So that we can easily find by substituting the value of tension, by substituting the value of acceleration in any of these equations. Let's say we substitute in the equation number 1. So we get m1 into g plus a naught minus m1 into this acceleration which we have just found, that is m1 minus m2 upon m1 plus m2 into g plus a naught, and that should be equal to T. So from this we would get tension T equal to 2 m1 m2 upon m1 plus m2 into g plus a naught. So this is the acceleration in the strings which is connecting both the strings. So let us move on to the next question. In the next question we have a big wedge which is accelerating to the right with an acceleration a naught. It is given that all surfaces are smooth and we are supposed to find what is the acceleration of block m1 and m2 in the figure which is drawn below. So m1 and m2 masses are sliding on top of this wedge which is moving to the right with an acceleration a naught. Action to gravity is given as g. We are supposed to find what is the acceleration of block m1. So we know that the magnitude of acceleration of m1 and m2 with respect to the wedge would be the same values, at least in magnitude. Why would it be same? It is because in the frame of reference of the wedge, the distance moved by the m2 block in downward direction would be same as the block m1 moved in rightward direction. So these two blocks, masses m1 and m2, we are saying that in the frame of reference of the wedge, they would be moving with the same distances. That is, the distance moved by m2 in downward direction would be same as the distance moved by m1 in rightward direction. And why is that? This is because they are connected to the same string. So at least in the frame of reference of the wedge, their acceleration would have the same magnitude. Now, would that be true in the frame of reference of, let's say, ground? So that would be no answer, because in ground frame of reference, masses m1 and m2 would have different kind of motion. They would also have to account the acceleration of the wedge to get the net acceleration of masses m1 and m2. So that would be complicated motion and not a straightforward motion. So mostly pseudo forces helps us in taking out these complicated scenarios, that if we were to do this question in the ground frame, then it would be much more technically tedious to do this question. So instead we choose a frame of reference in which it is very easy to see how masses m1 and m2 are getting displaced, and this would be a starting point for this question also. We would say mass m1 has an acceleration a in the rightward direction and mass m2 has an acceleration a in downward direction, and we already know that the wedge is moving to the right with an acceleration a naught. So let us draw the frame of free body diagrams of both the blocks masses m1 and m2 by a person sitting in the frame of reference of the wedge. So let's say for the mass m1, the forces acting on m1 would be tension T and the pseudo force. Now again, when we are applying pseudo force, we would say we would reverse the acceleration a naught, and after reversing the acceleration we would multiply this acceleration with the mass which we are trying to observe. So we would say m1 into a naught. That is what we would be applying. The upward force on m1, the upward force in m1 would be same as that if it were kept on ground, that is normal reaction, and the downward force on m1g. Now in this frame of reference, we have already decided that m1 is moving to the right with an acceleration a. So that is what we will be choosing as the acceleration in this frame of reference, and we would say that tension minus m1 a naught, that is the rightward force minus leftward force, should be equal to mass times acceleration in this frame of reference. So we get one equation. The second equation we can get by drawing the frame of reference of mass m2. So the upward force acting on mass m2 is the tension force, tension T. The rightward force acting on the mass m2 is the normal reaction, which is actually taking the mass m2 in forward direction. The backward force acting on mass m2 is the pseudo force, that is mass m2 and the acceleration of the system a naught, and the downward force is simply m2g. Now we have taken that mass m2 is sliding in downward direction, so the acceleration is a. So again we are choosing the direction to evaluate in which acceleration is happening, as it would give us the relevant equation containing it. So that's why we are choosing it. So in downward direction, the downward force acting is m2g and the upward force acting is tension. So it's a this net force is equal to the mass of the body which we are observing times the acceleration of the body, which is a. So after adding equation number 1 and equation number 2, which we have evaluated from these two masses, we will get m2g minus m1 a naught is equal to m1 plus m2 into a, or we would say that the acceleration of the masses m1 and m2 in magnitude with respect to the block. So m2g minus m1 a naught divided by m1 plus m2. So this is the acceleration of the both the blocks with respect to the wedge. So if the question were to ask you, or if in some scenario would have to calculate, if the question asks that what would be the net acceleration of the masses m1 and m2 with respect to ground. For example, here the question mentions that you have to find with respect to which, and that's it. So we discussed the scenario that what if we want to find the acceleration with respect to ground. So that is the idea, that we can evaluate the acceleration with respect to ground, but it is first important that we choose the frame of reference in which it is convenient to find the accelerations of the block with respect to the wedge first. After evaluating that acceleration, then we would switch to ground frame of reference, and that would be pretty easy to see actually. That will be adding the accelerations of the wedge vectorially to the accelerations of both the blocks m1 and m2, and we'd get the net acceleration. So let us jump to the next question. So this page contains how we solved this particular example, that is we choose the pseudo forces m1a0 and m2a0. The pseudo forces m1a0 and m2a0 are applied on the block as we are observing both the blocks in the wedge frame of reference, and after that the whole question is solved. So let us do question number 2. So in this particular question, we have a wedge which has multiple inclinations. So the wedge is inclined at two angles at two different points. So one angle is alpha, other angle is beta, and there is a pulley in the middle. There is a mass m which is kept on the angle of inclination beta, and there is another mass m which is kept on the angle of inclination alpha, and both are tied with the string. Again the same thing is happening. The wedge is accelerating to the right with some acceleration a on some smooth surface. Action of gravity is g. Find the value of acceleration such that all the bodies remain at rest with respect to each other in the frame of reference of this wedge. So if we are to observe this whole system, that is masses m and n with respect to the wedge, we are supposed to find that value of acceleration which ensures that m and m do not move with respect to the wedges, with respect to the inclines. So how to do that? Again, we will be switching to the frame of reference of the wedge, which is accelerated frame of reference, and we will be quickly drawing the free body diagram. So that is the whole point. First, switch to the frame of reference which is accelerated. You evaluate what we want to find. We want to find the value of acceleration. So we switch to the non-inertial frame in which it is easy to observe masses m and m are at rest. So it would be easy to observe, easy to calculate. And after that, we started deciding that okay, we will be drawing the free body diagrams. So let's say this mass is some mass number 1. So for first mass, we will say that what is the acceleration with respect to the moving frame. For the moving frame, the mass m is not moving. Normal reaction n, upward direction, gravitational force mg, tension T, and the pseudo force acting in backward direction. So this would be backward because the acceleration of the wedge is in forward direction. So we reverse that acceleration vector, and then multiply it with the mass which we are trying to observe, and the angle of inclination is some beta. Now as the system is at rest, we'd say that MA we know that this particular angle is beta, so we'd say MA cos beta, that is the component of the pseudo force along this incline is equal to the tension force and the component of gravitational force along the incline, which is mg sine beta. So the forces along the incline in downward direction should balance the forces acting along the incline in upward direction. And in the same way, we would say for the block number 2 that the block is on the incline, normal reaction is acting, gravitational force is acting, and pseudo force again acts in backward direction MA, except that now tension is acting in now upward direction as the string is like this. So it's a tension plus MA cos alpha is equal to mg sin alpha. That is, the forces acting along the incline in upward direction should balance the forces acting along the incline in downward direction. So adding these two equations, we'd get A cos alpha plus cos beta is equal to G sin alpha plus sin beta. So this implies acceleration is equal to G sin alpha plus sin beta divided by cos alpha plus cos beta. So this is the value of acceleration which should be maintained for the wedge so that the masses, both the masses M and M, do not slide over it. So with this particular question, we'll be putting full stop to this video, and in the next video we'll be continuing from question number 3 and doing much more questions. So thank you for joining and have a nice day.